The first law that I will be displaying is Charles's law, which describes how gases tend to expand when heated and how they contract when they are cooled. It is modeled by the expression V1 over T1 is equal to V2 over T2. In order to display the law, I blew up a balloon and measured its volume by using the water displacement method. I filled up a measuring cup to 400 milliliters, fully submerged the balloon, and got a final value of 900 milliliters, which means the balloon had an approximate value of 500 milliliters. I then put the balloon in the freezer overnight. The temperature inside the house was 76 degrees Fahrenheit, so the temperature was 297 Kelvin. The temperature inside the freezer was -4 degrees Celsius, so the temperature was 267 Kelvin. According to Charles' law, 500 over 297 should equal the balloon's volume divided by 267, meaning the balloon's volume should be near 450 milliliters after being put in the freezer overnight. The next morning, I took the balloon out of the freezer and measured its volume using the water displacement method. I measured out 400 milliliters of water into a measuring cup, and then submerged the balloon completely and measured the value to be near 875 milliliters, meaning the balloon had a volume of around 475 milliliters. The reason it could not be 400 milliliters is the balloon could have been warmed up by the air after it was taken out of the freezer, or by the water in the cup. Thus, the balloon would expand. The next law I will be displaying is Boyle's law. Boyle's law describes how the volume of a gas is affected by pressure. When the pressure goes up, gases tend to become more compacted, and vice versa. To display this experiment, I'm using a syringe holder, a 5-pound weight, and a 10-pound weight. I hot glued the end of the syringe in the hole the syringe stands in, so no air could get out or in. Then I applied the 5-pound weight and guided it with my hand. The 5-pound weight compacted the air to around 2.4 milliliters. The pressure applied by the 5-pound weight is 1.6 psi, because the pressure is the same as the weight, or force, divided by the area. The area of the plunger is just pi, because the radius is 1. Accordingly, the pressure from the 10-pound weight is 3.2 psi. According to Boyle's law, when the 10-pound weight is applied, the air in the syringe should compact to 1.2 milliliters. I applied the 10-pound weight, and it compacted the air to 1.2 milliliters. The results are exactly what were to be expected. Thanks for watching, and please go easy, Mr. Ahmed.